Hello everyone. Welcome to this week's lecture for Math 110. My name is Josh Munshi and I'm going to be your instructor for this week's lesson. This week we're going to be talking about conic sections, and as the name suggests, we are going to be looking at sections of a particular type of a cone. So let's go ahead and have a visual picture of what we're dealing with. So let's say we have this sort of cone. We call this double right circular cone or a double napped cone. If we have a particular plane, a two-dimensional plane, intersecting this cone, and we can kind of see the intersection here, there is a shape formed. This shape is called a parabola. We'll be looking at these shapes for this week's lessons. You can see that if this plane goes ahead and intersects the bottom part of the cone as well, you can see we have another shape. This shape is called a hyperbola. If this plane intersected the cone in this particular way, we have a shape, and I believe you're familiar with the shape. This is an ellipse. And these are all of the shapes we'll be looking at: the ellipse, the parabola, the hyperbola. There's also the circle, which would be formed if there was a plane that intersected directly horizontally with the cone, and we could visualize this. There we have a circle. Now, apart from these four, we do have a few other conic sections, but we will not be looking at it in detail. They're called degenerate conic sections, and they're formed usually when this plane goes somehow through the center, which is called the vertex of this double right circular cone. So if we have a look at this plane in 2D, you will see that we just have two straight lines that are intersecting. So this is a degenerate conic section. We have another degenerate conic section if, again, this is the plane that's intersecting the cone, and this is just a point. You can see there's just one point, and this is also a degenerate conic section. There is one more degenerate conic section, which is if we have a plane that slightly touches past one of the sides of the cone. So as you can see, it just touches past this cone. If we have a look at this in 2D, you would see that this is just a straight line. Okay, so let's go ahead and look at the standard equations for these shapes. So if we have a shape that, as you could see from the visualization, a shape like this, we know this is called a parabola. And I believe you're familiar with it already by now. A shape that is like this is, as we know, is an ellipse. If we have a shape like this, circle, and let's say we have a hyperbola, which looks like this. Since this is an introductory lesson, we'll be looking at the standard equations for each of these shapes in this video. So we know that this has the common equation y equals x squared. In conic sections, we'll be using a more standard way to write this, which is if we have x squared is equal to 4py. Now this equation, as we all know, uses the idea that the turning point, which we call the vertex here, is at 0, 0. However, if the vertex was, if this turning point was not at the origin of the graph, we would have an equation that looks like this. This is where the vertex or the turning point is at h comma k. So this is the standard equation for a parabola that has a vertex at hk. When h is 0 and k is 0, we have this equation. Knowing either of these or both of these are quite simple, so I believe that's not going to be difficult. The ellipse has the standard form. Well, if it was passing through the origin, we would see it has a form of x squared over a squared plus y squared over b squared is equal to 1. Now this is provided that a is greater than b, which means this shape will be longer on the x-axis. We'll talk about the technical ways in an upcoming video. But if b was greater than a, we would have a shape kind of like that, but we're ignoring that for now. I'm just going to look at this shape. And for this shape, if we did not have it centered at 0, 0, the origin, then the standard equation would be x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Now for circle, we have looked at it before, but we all know that this is the shape that comes up. X minus h squared plus y minus k squared is equal to the radius squared of the circle. If this was centered at 0, 0, we would have just x squared plus y squared equals r squared. And finally, we have the hyperbola, which has the standard equation x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Again, the center of this, not the vertices, the center about which this shape forms is h comma k. For this one as well, I have used the center h comma k. Same here. So these are the equations we would have to keep in mind. I'll kind of highlight them. So this is the parabola 1, ellipse, circle, and hyperbola. We'll be looking at a more general equation, and the name of that equation, we call it a general equation for second degree with two independent variables. That is one equation that will kind of incorporate all of these equations in it. That will be covered in the next video.